Okay, right. Welcome back. So, just sticking with this, these three heads that we have, the situation where n was equal to 3. Right. So here n was equal to 3. So, and we were able to find our probabilities, weren't we, from the last video? Now, there's two key elements here to finding our probabilities. First was the probability itself, which, if you like, was simply a multiplication of each branch, wasn't it? So I multiplied the 0.5 times 0.5 times 0.5. And that was the probability in this scenario, because here I only had one branch, if you like, with 3 heads. Right? I had one branch with 3 heads. So there's two things. First of all, I have one branch and I have the total probability multiplied by each other. So really I have 1 times 0.5 3 times. I mean, that's really what's happened, isn't it? 0.5 times 0.5 times 0.5. In this case, if the probability was what is the success of 2 heads, remember I have 3 branches, don't I? I have 1 branch here, 1 branch here, and 1 branch here. So really, in this scenario, I have 3 branches times 0.53. So where I'm trying to get to, and let's just do the next one. Here, when I have 1 head, I have 1 head here, 1 head here, and 1 head here. I have 3 branches again of 0.5s, don't I? Because I'm doing 0.5 times 0.5 times 0.5. And finally, I have, for no heads, I have 1 branch of the same thing. And now, this is really the explanation of any fancy formulas you look at. The fact that we look at 2 areas. We look at the number of branches, or the number of, if you like, combinations. And there is a formula for this, and I'll discuss that in a second. But so that you see where things are coming from, and then the actual calculations. Now remember, I think this is a good place to discuss this. Imagine that this had been 0.5 or 0.6 and this has been 0.4. Well, then I could sort of know that, well, if this was 0.6, for example, and this was 0.4, right? Well, I would have said, wouldn't I, that I would have said, well, this is all 0.6, and this is all 0.6, and this is 0.6, and this is 0.4, and this is 0.6, and this is 0.4, this is 0.6, and this is 0.4, and this is 0.6, and this is 0.4, and this is 0.4, and this is 0.6, and this is 0.4. Good. So I've changed that. I mean, all still at 1. This is, for example, an unfair coin. What I would have had here would be 0.6 times 0.6 times 0.6. So it will still be the 1 branch times 0.6 raised to the power 3. Well, for my 2 head branches, what I would really be having, right, would be a 0.6 times 0.6 times 0.4. So I'd have a 0.6 times 0.6 times 0.4. And I would have that in exactly the same way I would have for all my other 2 branches. I mean, remember, I have a total of 3 branches for 2 heads. So instead of 0.5 here, I would have something that looked like this. I would have 3 times 0.6 twice and 0.4, right? Whoa, where's that going? That's what I would have, right? Because I have 2 heads and 1 tail, right? So, and exactly the same thing here for my, when I only have the 1 head, I would have 3 times the 1 head times the 2 tails. Oh, goodness me. right? I mean, because that's what we're doing. I'm saying here where everything was the same, I was literally doing 0.5 times 0.5 times 0.5. Now I'm literally just multiplying 0.6 times 0.4 times 0.4. When I have the one tail and two heads, I would have 0.4. When I have two tails, I have 0.4 times 0.4 times 0.6. So but I have three of them, don't I? Because I have a scenario where I have one head and two tails. I mean, whenever you see one head, I mean, the total is 3 throws. So when one head means one head, two tails, doesn't it? And so in this very scenario, I would be having 3 times, sorry about this, my pen is really messing up. I would have 3 times, well, 0.4 power 3. I mean, you know, and then, well, I don't have any 0.6s, so that's 0. You could recognize it that way, because that's what we have here. And up here, the very first one, where I have 3 heads, I would have 3 times 0.6, 3, and, well, I don't have any tails, so I could do that. I mean, you don't have to, but if you wanted to make everything look the same. So this, if you like, is the origin of any formulas we're going to look at in the next video. But everything has come from, again, like I said, the two important things in order to be able to work out these probabilities was for me to find the probability itself, which is what I do, which is all of these, and then the number of branches, right? And that's pretty much how we arrive at the probabilities for any of these individual scenarios. Okay, great stuff. So what I'll do in the next video is show you a formula that we use, and then also kind of take it to Excel and to how it's sort of done as well. Okay, great stuff. See you then.